everyone, and welcome back. Today on the menu, we've got graphs, and it's real life graphs, and hopefully you're going to enjoy this real life graph screencast, because what it does, it takes statistics and data and it puts them into real life context, which is always something that we can relate to. And that's what we've got to try and do, is we've got to try and relate to the information being shown on the graph before we answer any questions. And often that is key in maths. Actually, before you answer a question, try and get yourself into the information before you look at the question. And that goes for lots and lots of parts of maths. It'll really help with our cognitive load, which means that we can just take things in bite-sized pieces rather than trying to take everything at once. So we're going to go through some examples of that today. But what are real-life graphs? Well, very simply, using graphs is not just about reading off values. In real-life context, so real-life graphs, the intercept, gradient, and area underneath the graph can have important meanings such as fixed charge, speed, or distances, and that's from BBC Bite Size. This is an example. So a long, long time ago, when the dinosaurs were roaming around, Mrs. Warren and Mr. Warren were in New Zealand, and we went and did a bungee jump. And this graph represents that bungee jump. And that's the type of things we're going to look at today. So let's have a look at an example. And as I said, let's read things and not go on to the next thing until we've done that. So let's read what this graph is going to represent. Mr. Warren drove his son, from his home to the train station to drop off his son. He stayed at the train station until his son left and then drove home, only stopping at the petrol station to fill up. So now we're going to bring up the graph. We're going to bring up the y-axis values. We're going to bring up the x-axis values. And we can see here that the y values represent distance from home in kilometres. So we can see we're starting at 0 and we're going up in 10, 20, 30, 40, 50, 60. What's important here is that we understand how much each line is worth. So each line is worth 5 kilometres, isn't it? 5, 10, 15, 20, 25, so on and so forth. That's really important. So we can see here that we're starting at 0 and we're going up towards where? Okay. On this side, we've got time of day. So we can start at 1 o'clock, that's 1300, and the graph finishes at 1700, which is at 5 o'clock. So now that we've looked at that, we can now have a quick little look at the graph, and we can see we're starting at 0. Mr. Warren drove from his home to the train station. So drives from home to train station. He stops. Yeah. He stays at the train station until his son left. He stays at the train station until the son left. He then drove home, only stopping to fill up at the petrol station, and then obviously continues. So that's what that all means. Now let's look at the questions. The 3 questions we've got here, we're going to go through each one at a time. One at a time. How far does Mr. Warren live from the train station? Well, let's have a look. Mr. Warren drove to the train station and to drop his son off. So we can see here that he's at the train station here. So how far is that? That's 50 kilometres. How long did he wait at the train station before his son left? So remember, it says here he stayed at the train station until his son left. So he stayed at his train station until his son left. So it's between this line here that goes down and this line here. And this is something I'd highly recommend as we go through. Use your ruler to make sure that your values are bob on. And we can see that, what did we say? That we didn't say actually, each of these lines is worth 10 minutes because I've got 10, 20, 30, 40, 50, and we're on an hour, aren't we? So each of these lines is worth 10 minutes. So I've got 10, 20, 30, 40, and 50. So we should have 50 minutes. And last but not least, how long was Mr. Warren driving for? So you've got to remember that these flat bits, Mr. Warren is not driving for. So let's have a look here. These flat bits, Mr. Warren's not driving. So we're looking at this bit, and this bit here. So I've got to add all these little bits up, remembering that each of these is worth 10 minutes. So the first section is worth 50 minutes. The second section is worth 30 minutes, and the last section is also worth 50 minutes. And if I add all of those up, I end up with 2 hours and 10 minutes. So we can see there how this all works. Definitely use ruler where appropriate, please. So although I did all of that one myself, and although I'm not expecting you to draw this out, if you did, that'd be fantastic. I would like you to go through this process with me. I'm going to bring up all the information, and then I want you to go through it on your own, come up with your answers, and then check if your answers are correct. So let's bring up all the information now, all the questions. There's one more there. Pause the video here, look through all the data, give it all a go, then come back and see if you've got it correct. So first up, Mr. Owen loves his chocolate, although he is trying to cut down. Yeah, that's very true. That's very true. He goes to the shop and buys his favourite bar and slowly eats it. Oh yes, I can even just think about it now. This is the weight of the item, and remember each of these is worth how much? So 5, 10. So again we've got 5 grams each line. This is time in minutes, so each of these is worth half a minute, which is quite important as we go through. So graph starts at 0, 0 and goes up to 11 minutes and goes up to 60 grams. So now let's look at the graph, and we can see here that the bar stays the same weight until 2 minutes, and then at 2 minutes it loses weight. Okay, it stays that weight for another 30 seconds and then loses weight and then stays that weight for, it looks like, a minute and a half. You get the picture until it weighs nothing, until Mr. Warren is full. So let's have a look at the questions now. How much does the bar of chocolate weigh? Well, we can see here it weighs 60 grams. So we're going to bang in there, that point there, we're going to bang in there 60 grams, aren't we? How much does the chocolate weigh after 5 minutes? So we would draw a line going down and a line going across, and we would say, okay, remember each one of these is worth 5 grams, so it's going to be worth 25 grams. How long does it take for the chocolate bar to be eaten? Now, 2 possible answers here. You could say it was finished eating at 10.5 minutes. I think this is actually saying how long did it take before. No, that's right. So the first one will be 10.5 minutes because it's finishing here, isn't it? Yeah, it's finishing right there. So it's going to be 10.5 minutes. How long does it take before Mr. Warren took his first bite? So this time we're looking at this, yeah, where it obviously weighed 60 grams and then the first bite happened here. So it took 2 minutes. 2 minutes. So there we go. That's all the information on that one. We're getting close now, everyone. We've got a couple more to do. We've got this bungee jump one. So as I promised, here goes the bungee jump one. Distance from the water in meters. Time in seconds. This is a little bit tougher, this one. Here goes all the questions. Pause the video now, give it a go, and come back and see if you've got it right. So here we go, Mrs. Warren doing a bungee jump in New Zealand. Okay, distance from the water, time in seconds. So we can see here that we're going from 110 meters down to 0 meters. We're going from 0 seconds to 11 seconds or 12 seconds. Okay. So now let's look. Obviously we're starting 110 meters above the water, and we're going down to 5 meters before we hit the water. So you've got to think about that. Then we're going back up towards wherever you were jumping from, then down towards the water, then back up, then down, then back up, then down, then flat, and then this quite quick curve back to the earth. So we've got to bring some meaning to all this. How high is the bungee jump? Well, we can see here that we're starting at 110 meters. So hopefully we would put 110 meters. Why does the graph zigzag? Because if you don't know how bungee jumps work, you go down and then you go spring back up and then down, then spring back up. So you go up and down, bounce up and down. How long is the person, Mrs. Warren, falling for until it should be they begin to bounce back up? So we can see here that we're falling for a full second, before we bounce back up. Why does the person stop at 5 meters and not at 0? Hopefully you'd realize you don't want to stop at 0. Although in saying that, when Mr. Warren did his one straight after Mrs. Warren, he actually touched the water. So I did stop at 0. You don't want to hit the ground or the water. How long is the person not bouncing but still upside down? Now, you could have had two possible answers. You could have gone from this point here through to this point here. But actually, if you know how it works, you're upside down until you get back down. Okay, and what happens is you bounce up and down, then you stay stationary, and then they literally pull you down. So it goes all the way through. But I would accept, a couple of answers here. So remember, each one of these is worth 30 seconds. So we've got 30 seconds, 1 minute, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, or we would have had 7.5 seconds. So 6.5 or 7.5, I'm happy with. And it is time now for the quiz. This one I do want you to copy out. I want you to copy out this question in full. Here goes the questions for you. Please pause the video now, give it a go, and then come back and see if they've got it correct. All right, everyone, here we go. Here goes the answers. Let's quickly go over the question, though. Bolt Lightning is running in the Olympic 100-metre final. The graph below represents his race. Distance in metres, time, both starting at 0, which is the origin. And let's go through the answers now. So how far has he ran after 4 seconds? So we would have drawn a line and gone through. Now, if you said 40, I'm happy with that, but it's actually a little bit more. It's 41 metres. How long has it taken Bolt to run 110 metres? So it's taken him the full 12 seconds. How far has he ran after 8 seconds? Again, we put a point there. And again, if as long as you're in there, remember each one of these is worth 10. So I've put it at 5, so 85. And is the graph a true representation of this race? Explain why. The answer is no. His speed should increase. So we can see here, he started in his blocks. He's going to build up speed to start, isn't he? He's not going to run at the same speed from the start to the end. If he was doing that, he'd need a running start. So this is not a good representation of his race. So there we go, everyone. Hopefully you've done well. I'm sure you have. Hopefully you've somewhat enjoyed it. Until next time, it's been a pleasure helping you with your maths today. Remember, every day, if you get a little bit better, before you know it, you'll be amazing at maths.